The next thing on our list is to study a new functional group, or a new set of functional groups. Sections 14.1 and 14.3 are going to be an introduction and also rules for naming or nomenclature of the three new functional groups that we're going to look at. So in chapter 14, the functional groups that we're going to study are the alcohol functional group, the ether functional group, and the alkyl halide functional group. I'm going to draw an example of each one of these types of molecules. First of all, I want to say that the alcohol is a molecule that contains an oxygen-hydrogen group. An ether is a molecule that contains a really unique bonding situation, a carbon single bonded to an oxygen that's single bonded to another carbon. And the alkyl halide is a molecule that contains a carbon that is bonded to a halogen. And we use the letter X in organic chemistry to represent any one of our halogens: fluorine, chlorine, bromine, iodine. Those are the four that we see the most. So an example of an alcohol would be, I'm going to use condensed notation, CH3, CH2, OH. And that OH is what makes this molecule an alcohol. Now it's really important that you see that the OH group of an alcohol is by itself. So for example, if we were to have a molecule like this, where the OH group is with another functional group side by side, that is not an alcohol. That's a different type of molecule that we'll study later. The alcohol is a molecule that has the OH group that's attached to just a regular, plain, boring carbon-hydrogen chain with nothing else. The ether functional group, so this is, like I said, it's going to be a carbon that is bonded directly to an oxygen, which is bonded directly to another carbon. So that's going to be something like this. And there's the ether part of this molecule. And then the alkyl halide functional group is pretty easy to spot. It's just going to be like, let's put a bromine on there. A bromine that's attached to a carbon that's part of a carbon chain. Of these three functional groups, we have already talked about how to name alkyl halides. That was something that we did in the first week when you were learning just real basic naming. We're not going to learn how to name ethers. We are going to learn how to name alcohols. The good news about naming alcohols is that it follows the same type of rules that we have been using for naming alkenes and alkynes and alkanes and alkyl halides. We just continue to use the same rules over and over again. And so, as you know by now, our first step always is to find the longest chain of carbons, the longest carbon chain in the molecule. Now, when we were learning how to name alkenes and alkynes, our job was not just find the longest carbon chain. Our job was find the longest carbon chain that includes the double bond or the triple bond. And that's going to be the case with alcohols as well. Find the longest carbon chain in the molecule that includes the OH of the alcohol. That's going to be important. we are going to number that carbon chain. When we numbered carbon chains, every molecule so far, when we've numbered the carbon chain, we've always started at the end closest to the functional group in the molecule, and that's the same in this case as well. So we're going to number the carbon chain starting at the end that is closest to the OH of the alcohol. So that rule hasn't changed. And then what we're going to do is apply all of our rules, our normal rules, for any substituents that might be on the molecule. So that means that we're going to locate those substituents, we're going to name them, and we're going to put them in the front of the molecule's name in alphabetical order, not in number order. So we're applying all of those regular rules for substituents. And the last thing that we are going to do is name the parent chain This is going to be based on how many carbon atoms are in the parent chain. It's the same as what we've always done. In this case, though, with an alcohol, we are going to drop the E off the ending of the alcohol's name, and we are going to replace it with all for alcohol. So this is similar to what we did with alkenes and alkynes. When we were naming an alkene, we dropped the ane and replaced it with ene. When we named an alkyne, we dropped the ane and replaced it with ine. With an alcohol, we drop just the E and replace it with all. So for example, if we had hexane and we needed to turn that into an alcohol name, we would drop the E and say hexanol. So let's look at a couple of examples for naming. I'm going to start with one that's in condensed structure because it's tiny and hard to draw in a line structure. So our first job is to find the longest carbon chain, and there's only one carbon, so that is the longest chain. And we are going to number that single carbon starting at the end closest to the alcohol, the OH, and there's only one carbon. Apply any rules for substituents. Well, this molecule doesn't have any substituents, doesn't have any branches, so we don't have to worry about that. And then we are going to name the parent chain. A 1 carbon molecule is methane, but because this is an alcohol, we're going to drop the E and we're going to replace it with all. So this is methanol. That one was pretty easy. So let me give you one that's a little bit trickier. So now here's this molecule. We only have 1 carbon chain, so we don't have to worry about finding the longest carbon chain. We want to number on the end, starting on the end closest to the OH, which means we want to start on the right and move to the left. We don't have any substituents on this molecule, so we're ready to go straight to the name. Oh, and this makes me realize that I have forgotten a rule in your steps 1, 2, 3, 4 for naming alcohols. We have to say where the OH is located, and that's the part that I left out of your steps. So what we have to do is name the parent chain, 5 carbons. This is pentane. We have to drop the E and change it to all because it's an alcohol. What we also need to do is give the location of the alcohol. So this is 2-pentanol, and let's squeeze that rule in up here. name the parent chain, drop the E, add the all, give the location of the OH, the location of the alcohol, and it's going to be in front or before the name of the parent chain. All right, let's do one more of these, and then we're going to go to a worksheet with a few more examples. So here we have a cyclic, which means that that 5-membered ring is going to be our longest carbon chain. We want to number our ring starting at the carbon that contains the OH, closest to the OH. So the OH is going to be on carbon number 1. And then we want to number either clockwise or counterclockwise in a way that will give our other substituent, chlorine, the smallest possible number. So in this case, we want to number clockwise so that chlorine ends up on carbon number 3. If we numbered counterclockwise, I'm going to do that in blue, chlorine would end up on carbon number 4. And that's not what we want. We want to give the chlorine the smallest number that we can give it. So now we're going to name our substituent, locate and name our substituent. Our substituent is on carbon number 3. Our substituent's name is chloro. Now we locate the alcohol. It's on carbon number 1. We give the name of the parent chain. It's a cyclo because it's a ring. It's a pentane because it contains 5 carbons. But it's not a pentane, it's a pentanol because it's an alcohol.